in terms of graphing these guys, when you take a look at graphing y equals 10 to the x, the exponential, we knew how to do that. We said the easiest thing to do was the bend, and the bend in the graph was negative 1, 0, and 1. This would give me 1/10. This would give me 1. This would give me 10. He has an HA at y equals 0, and of course his domain is all real numbers. That's what you need to know about the exponential. So the first thing I always do that helps me with any graph, if there's anything in there that's special, I put that in first, and he has an HA. And the HA governs his behavior, and the HA is y equals 0, so I put that in because he's going to ride along the HA. That's why I only need the bend. And at negative 1, it is 1/10, very close to the x-axis. At 0, it's 1, and at 1, it's 10. And then I connect the dots. You notice he goes off very, very fast. He's very, very steep, and then he's going to ride along the y-axis. So that's the exponential. The thing that we learned is that the logarithm and the exponential are inverses of each other. That means in order to graph log base 10 of y equals log base 10 of x, I'd flip x and y. I'd flip x and y. So that where I had an HA, I'd now have a VA. Because x's and y's flip. So I said, well, how's that going to help me graph these things if I have to graph this sucker, especially using transformations, right? Well, you got to deal with the basic graph. The easiest thing to do when dealing with a logarithmic function is knowing something about it and knowing that his domain is 0 to infinity, and that he has a VA at x equals 0. The base on this logarithm is 10. So I'm going to rewrite this guy as x equals 10 to the y power. I know that's a squirrely looking 10, and that's because I almost wrote a y. Let's get rid of the evidence, except now it's going to be videoed into place forever. Well, at least for this semester. And so how is that going to help me? The way this is now written as a basic function is I can now put in y's and x's can come out. So that if I think about how this is going to work in terms of the graph, in terms of my T-bar chart, he has a VA at x equals 0. It's x equals 10 to the y power. Now, what do we say we needed to do? We need to flip x and y. Flip x and y. Now, instead of putting in -1, 0, and 1 for x, I'm going to put -1, 0, and 1 in for y. Now, this becomes y to the -1, which is 1 over 10. This is going to be 10 to the 0, which is 1. This is going to be 1 to 10 to the 1, which is 10. And if you notice, everything between these two graphs is flipped. X's and Y's are flipped. VA, HA is flipped. It's flipped. They're inverses of each other. So if you have to do these suckers by hand using transformations, go after the basic. And realize that what you put in X for X before, you're going to put in for Y now. Now, how does that work for me? Again, I first put in the most important piece of information, which is my VA. And it's X equals 0. That's your VA, vertical asymptote. And it says if X equals 1/10, Y equals -1. If X equals 1, Y equals 0. If X equals 10, Y equals 1. And he looks just like the exponential flipped. Now think about if I do a 90 degrees flip on the logarithm, who does he look like? In other words, I flipped X and Y. He looks like an exponential. If I do a 90 degree flip, X and Y, there's your log. They behave exactly the way you want them to behave. So for me, if I'm going to have to do this thing using transformations, and if I were to look at Y equals log base A of X, I would rewrite, and it's going to be X equal A to the Y power. There's my T-bar chart. I put in my favorite points, and off I go. We're only dealing now with the basic function. And of course, they're going to drag you through transformations.